This is MEI Statistics Minor, Discrete Random Variables for the Geometric Distribution. 4.2, Calculating Probabilities. So we recall from the last video that if x is distributed geometrically with probability of success p, then the probability that x equals x is p times 1 minus p to the x minus 1 for all x a member of the set of natural numbers, otherwise known as the positive integers, or 0 otherwise. And we remember that it is the number of independent Bernoulli trials necessary for the first success, including that first success. So the example we did last time was find the probability that the third child born into a family is the first female. If you're approaching this using a geometric distribution, we would say let x equal the number of children before the first female and x is distributed geometrically with probability of success 0.49 to 2 decimal places. So the probability that x equals 3, so the third child is the first female, is equal to p times 1 minus p squared, so that is 0.49 times 0.51 squared, which is 0.127 to 3 significant figures. So the next example is in a dice game. We define a double to be throwing the same number on 2 dice, and that must be obtained before a player can start. So we need to find the probability that a player starts within 4 attempts of throwing 2 dice. So if we let x equal number of throws before a double, we know that the probability of getting a double, since there's 6 possible numbers we can have and there are 36 possible outcomes, that means the probability of getting a double is 1/6. So x is distributed geometrically with probability of success 1/6. Now we want the probability that x is less than or equal to 4. So that's the probability that x is 1, plus the probability that x is 2, plus the probability that x is 3, plus the probability that x is 4. Using the formula, that is p plus p times 1 minus p plus p times 1 minus p squared plus p times 1 minus p cubed. Pop in our value of p, that is going to be 1/6 plus 1/6 times 5/6 plus 1/6 times 5/6 squared plus 1/6 times 5/6 cubed. Pop it in your calculator, we get 671 over 1296, or 0.518 to 3 significant figures. Alternatively, a quicker method would be to consider the probability that x is less than or equal to 4. That is the same as 1 minus the probability that x is greater than 4. And if we think about this contextually, that's 1 minus the probability that there are no doubles in 4 throws. once you think about it that way, that's going to be 1 minus 5/6, which is the probability of not getting a double, to the power of 4, which again gives us 671 over 1296. A further alternative is if you have a graphical calculator, some have a geometric cumulative probability distribution that you can simply output the answer from. So in our final video, we're going to be looking at the mean and the variance.